All right, good afternoon, everybody. My name is Raguet-Schofield. I work in the user interface department at Wolfram Research, and I spend my time working on mobile apps, mostly on iOS. And I'm going to talk today about running Wolfram language and Wolfram language generated content on iOS devices, and what are some of the options that we have to do that. So first of all, the question that you have to figure out kind of up front is whether you want the computation to be done on the device or whether you want computation to be done in the cloud. And as far as on the device goes, we have an SDK for iOS called CDF-Kit. And this is something that you can use and embed in your iOS app. And it will display CDF documents. It will perform evaluations using a Mathematica kernel, Wolfram language engine. One of the downsides to this is that it does require a custom app. It requires you to write code in Objective-C or in Swift. The upshot, though, is that it is very interactive, very responsive, beautiful, and it's relatively fast and getting faster with each new product release from Apple. As far as computation in the cloud goes, there are some options with Wolfram Alpha. There's some stuff you can do with Wolfram Cloud Documents that's going to work on iOS. And finally, the Wolfram Cloud, you can use it to generate your own custom API and call that from an iOS app. So as far as CDF-Kit goes, this is the native stuff that's running on the device. As you would expect, we support all the typesetting constructs, and they look quite nice. And in this interface here, I can just pinch and zoom, and we have great-looking typesetting. Even some of the more complicated things, like all the weird options to grid, these things are supported. Various Unicode character ranges, rotation, etc. All the typesetting stuff is there. It all works and looks nice. After typesetting, we have graphics. This is 2D stuff with nice-looking transparency. All the various 2D primitives are supported. 3D graphics. And as you can see here, this specific graphic has transparency, and this is something that we couldn't do a year ago when I was giving a similar talk to this one. Transparency in 3D graphics is hard. We have that now, and it's still nice and fast. I can touch it, I can rotate it, and one of the nice features we have is that I can take it and I can toss it, and it will just keep going without my finger constantly on the screen. Next up, dynamic. Anything you can do with dynamic should just work. So here I have a control, it's a checkbox, and a graphic whose background color depends on the value of this checkbox. So I can tap on the checkbox. You can see the graphic changes as we expect it to. And taking all those things and combining them, we have manipulate. Now, there's some interesting things about manipulate on a touchscreen device. First of all, the default control placement for manipulate, it has the controls placed above the content. And if you're using a touchscreen device and you're touching the control above the content, your hand is covering the content. So you can't actually see it. So that's not what the experience we want to have on iOS. So what we do is we take the controls and we put them down at the bottom of the screen so you can interact with the controls and still see the content that you're working with. Now, manipulate has an option, control placement, which allows you to move from the default location above the content to either the sides or the bottom. On iOS, we're ignoring that basically because manipulates written with that option weren't really taking touchscreens in mind when somebody decided to move where the controls are. But there's a way to get the controls in a different location, which I'll get to in just a little bit. And even with the 3D graphic, we still have reasonably good performance here. And inside the manipulate, we can still rotate our 3D graphics. Okay, so CDF-Kit is an iOS SDK. You can embed it in your iOS app to display and interact with CDF content. This is either pre-generated, maybe in files that you include with your application, CDF files, and you just read those files, and they work like that. Or you can programmatically generate the content at runtime. You can perform evaluations of Wolfram language expressions without any user interface. This all happens in the background. It takes advantage of multiple cores on the device. All the modern iOS devices have dual-core processors, and the recently introduced iPad Air 2 actually has a triple-core processor. So we can do more stuff in the background than ever before, and that's the direction all this is going, more and more cores. So what types of apps can you build with this? So the app that I'm using that's showing up on screen right now is built with CDF-Kit. I have a bunch of documents. I have kind of a navigation structure. I have a table of contents here with the various slides in my presentation. The documents scroll when they're too long to fit on one screen. There are demonstration applications, which is kind of similar to this, but it's filled with content from the Wolfram Demonstrations project. And here's a quick example of that. So this is demonstration. Demonstrations are built around manipulate, so I can tap the manipulate to activate it. I get some controls here. And since this is a 3D graphic, I can rotate it as I interact with it. So that app is built with CDF-Kit and just bundles a bunch of demonstrations together. Along those similar lines, we can do ebooks that were authored as CDF documents with table of contents, index, that sort of thing, and a paging mechanism similar to what we have here. But the CDF content doesn't have to occupy the entire screen like my content is here. We can also occupy just a tiny section of the screen, and you can have custom UI built all around it. And one example of that is the Wolfram calculator, which is something that is nearing completion and will be released fairly soon, we hope. So if you haven't seen this, this is Wolfram's take on a scientific calculator for iOS. It tries to minimize the amount of typing you have to do by providing predictions for the type of operations you want to perform based on what you've typed so far. So if I type sine of x, I can just hit I don't have to type that I want to plot. I can just hit that button. It says graph, and it makes a graph of the function. And here is another example app that we include with the CDF-Kit. This is called Molecules, and this is, we have one pane of CDF content here, and then we have a custom UI built around it where we can pick and choose different molecules, and it just displays the molecule plot for those. And we can rotate them, we can zoom in, and explore these. So those are the types of apps we can create. Building this into an app is not too difficult. So this is some Objective-C code. First thing to do is we want to create a CDF session object. And this is what maintains the kernel variable state for the app. Kicks off a kernel running on some background threads and enables a mechanism to communicate with that. Next, we create a CDF document and a CDF view controller. And if you've done iOS development, the concept of a view controller is no doubt quite familiar to you. And this just builds on that. We take the view controller's view, add it to our view hierarchy, and it shows up on screen. Then when we want to perform some evaluations, we have this evaluator object that will do that. So we use the concept of an expression, and we represent that as a CDF expr type. And we can create those programmatically. We can parse them from hard-coded strings. We can read, Wolfram language content from a file and construct it that way, or we can get it back as the result of a kernel evaluation. So we have the evaluator. We call this method evaluate expr preemptive queue handler, which is a bit verbose, which is also not foreign to you if you've written Objective-C code before. But that basically just says, here's an expression I want to evaluate. Here's a function I want you to call when the evaluation finishes. And once that evaluation finishes, we can take it, we can stick it into our CDF view controller's view, and that content will just appear on screen. So there's a number of system frameworks that CDF-Kit relies on that you have to link against in your application, along with a few libraries we provide. There are system files that CDF-Kit relies on. If you've ever looked inside of the Mathematica installation directory, you've no doubt seen the hundreds of system files that are there. All those files are very important to the operation of the system, and they need to be there, so your app has to include those, and we provide those along with CDF-Kit. We have fonts that we need to use to render the math correctly. And in order to, so you have to include the font, and then you have to add a few keys to your info plist to tell the OS to activate those fonts. And then finally, there's a couple minor things that you need to add basically to help kickstart the system. Hopefully these are temporary, but that's the way it is for now. So back to this molecules example that I just showed. This is, it reads the data from a very simple data file, and the data file was generated with 2 lines of Mathematica code. So first of all, just get a list of all of the chemical data salt types and get a molecule plot for those. Wrap that in compressed data, dump it to a file. And then at runtime, get the data out of that file and call this method CDF-expr with compressed data. And everything is in your app at that point. So there's a few additions we've made to the system to better support touchscreen devices. So the idea of mouse position doesn't really make a whole lot of sense on a mobile device since there's no mouse on iOS in particular. So that's not terribly useful, but you do have fingers that touch the screen, so we have a corollary, an analog to that, which is touch position. And the difference between the two is that mouse position always returns exactly 1 pair of points, whereas touch position will return an arbitrary number of points. So if I touch the screen, I get a single point. I can move that around. It changes. If I touch the screen with another finger, I get 2 points. And I can keep going on as many as I feel like. I only have 10. So the types of things you would do with mouse position for a desktop version of Mathematica, you would do with touch position using CDF-Kit. Gesture handler is similar to event handler, but instead of doing mouse pressed, mouse moved types of events, we have various gestures that it will recognize. And so I have an example here that recognizes a tap gesture, for example. I tap on it, it changes the background color and cycles between red, blue, and green. And then it has a drag gesture handler that when I drag from side to side, it changes the radius of this disk here. And I apologize, there's a redraw glitch that I only noticed after I put this on a Retina device. It didn't happen on a non-Retina device. So that's our problem that we'll fix, obviously. But I'm just dragging my finger back and forth. And aside from the redraw glitch, the size of the disk is changing along with it. Touchscreen control placement. So this is the option that I alluded to earlier. If you really want the manipulate controls to not be at the bottom of the screen, you can change that with touchscreen control placement. And so in this case, I have a vertical slider, which if you had it at the bottom of the screen would take up a lot of vertical space and very little horizontal space, so that doesn't make much sense. So in this case, I'm just going to move it to the right, and now I have a vertical slider over on the right side of the screen, and I can still work with my manipulate that way. And finally, touchscreen auto zoom, which is an option you can pass to manipulate, that if you want the manipulate content to be very immersive, we can zoom into it and have it fill the entire area when you activate that manipulate. That's not the default value. By default, we just kind of make sure it's visible and keep everything the same size. Okay, a few potential issues using CDF-Kit. There are a number of features which are still incomplete at this point that we'll have to work on getting support for in the future. Event handler doesn't make a whole lot of sense on a touchscreen device, although the mouse-clicked event handler is actually hooked up to a tap gesture on the device. So that one will work, but other types of event handler won't. Tab view, texture are not implemented. Locator works inside of manipulate, but not out. Input field's not implemented. There's some issues with arrows. Not all the customization of arrows are supported. And then there's a few areas of functionality that in Desktop Mathematica require Java functionality, and since we do not have that on iOS, we don't currently have those features. So network functionality, Wolfram Alpha, JLink, database link are things that we don't have right now. Other issues, performance to think about. This is not a desktop computer, although I said they are getting much faster, and the newest device actually has a triple-core processor, which is quite fast. But still, there's not a lot of RAM in these devices. So if you're doing computations that require lots of RAM, you'll have to do a lot of testing, make sure that they can still be done on this device. And it is slower than desktop and laptop computers. And due to the way the OS works, the kernel is integrated into the app. It's part of the process. It's not running as a separate process like it does on desktop systems. And we currently don't have a way to restart a kernel session. So once the app starts, that's the kernel session you have until the app is done. So as far as computation in the cloud goes, one option for that is to use Wolfram Alpha. Here is a screenshot from the Elements ebook application, which integrates Wolfram Alpha with it. There's an area where you can click Wolfram Alpha, it pops up, and it computes, and it shows the Wolfram Alpha results. And oops, you can see that real quick. If I just go here, there's a Wolfram Alpha button in the lower right-hand corner. So we have Wolfram Alpha. If you are doing an app where it makes sense to have Wolfram Alpha type results in your app, this is something you can do. The Elements has been doing it for several years.
What kind of restriction is that? Can you do a certain number of queries per day, or does the developer put the bill, or what?
I don't know the precise answer to that. It's not completely free and unencumbered. There is some cost associated with it. I don't know the exact details.
To the user, or you don't know that?
Well, it would probably be to the app developer.
The app developer is making a license with us,
Right.
and it would be under the conditions of that license, which I don't know the details either, but if you're seriously interested, we can talk about that.
I was just curious. That's it. That's a sufficient answer. Thank you.
Alrighty, Wolfram Cloud. This is something that we have. We have a Wolfram Cloud app for iOS that is progressing nicely, and we hope to release soon. If you have content that you want to work with on an iOS device, this is certainly an option for that. And will this is an option that will not require any custom code written in Objective-C or Swift on your part. You don't have to write a custom app. You can just use, this Wolfram Cloud app. And we can interact with these things. And this all works. And I'll show one other thing while I'm in here. This is just basically the exact demo Stephen gave during his keynote yesterday morning. I tried to reproduce it exactly. I may have transposed one or two of these functions, but the idea is that it creates an API function in the cloud that takes two parameters, a cat breed and an angle between 0, which is a number between 0 and 360. Then it finds an image of that cat, magnifies it by 2, rotates it by the angle you pass in, and returns a PNG format image. And I've already written that function. I have cloud deployed it. And that's going to bring me to my final slide here. You can create an API function in the Wolfram Cloud. And if you want to deploy that on iOS in your standalone app, you can do that with just a tiny bit of native code. If you look at the creation date of this file, I did this today. It took me maybe a half hour to write this application. And this is similar to what Arnaud showed yesterday for Android, but this is just the iOS version of it. So we have a view controller, and this is written in Swift, just to show a slightly different version of what you can do. So we have a user interface that has a couple of text fields. It has an image view, an activity indicator. It does a little bit of initialization in this viewDidLoad method. It does some form validation, which is not strictly necessary, but makes for a better user experience. And that happens in text field should return. And then finally, all the interesting stuff happens inside of this perform query method. So if we look at perform query, this is not a huge function. And a lot of the stuff that it's doing is just user experience stuff. It will disable the text fields while the query is happening. It hides the previous image. It will show an activity indicator spinning, indicating that the query is happening. And then when it returns, we make sure that we got an image back. We stick it in the image view, and we re-enable the text fields. So not a whole lot of Swift code necessary to make this application work. And here it is. I can do Siamese, which is actually the only cat breed I knew as of a couple hours ago. We can rotate that 45 degrees. We see our little activity indicator, and then we get the Siamese cat back. And this is a fully custom iOS app that I wrote in 30 minutes that used the cloud deploy function that I borrowed from Stephen's talk.